Welcome to the world of C programming operators. In this lesson, you'll discover the fundamental building blocks for creating expressions and performing operations in C. Operators are special symbols that perform specific operations on 1, 2, or 3 operands, and by the end of this guide, you'll have a solid understanding of the core operator types in C. These include arithmetic operators, relational operators, logical operators, bitwise operators, assignment operators, and special operators. Let's dive in and explore each category in detail. Let's explore arithmetic operators in C. These operators are used to perform common mathematical calculations. The addition operator denoted by a plus sign adds 2 operands. For example, a plus b. The subtraction operator, denoted by a minus sign, subtracts the second operand from the first, as in a minus b. The multiplication operator denoted by an asterisk multiplies 2 operands, as in a times b. The division operator denoted by a forward slash divides the first operand by the second, as in a divided by b. The modulus operator denoted by a percentage sign returns the remainder of dividing the first operand by the second, as in a modulus b. The increment operator denoted by plus plus increases the value of a variable by 1, and can be used in prefix form like plus plus a, or postfix form like a plus plus. The decrement operator denoted by minus minus decreases the value of a variable by 1, and can be used in prefix form like minus minus a, or postfix form like a minus minus. Increment and decrement operators are essential tools for modifying variables in C. Let's clarify the difference between prefix and postfix forms. Prefix operators modify the variable before its value is used in an expression. The plus plus variable increments the value, and then returns the updated value. The minus minus variable decrements the value, and then returns the updated value. Postfix operators, on the other hand, modify the variable after its value is used in an expression. Variable plus plus returns the original value, then increments the variable. Variable minus minus returns the original value, then decrements the variable. The key differences to remember are that the prefix operation happens before the value is used, while the postfix operation happens after the value is used. Both modify the original variable, and this difference matters in expressions and assignments. Consider this example. We initialize integer and integer b to 5. If we use the prefix increment, as in result 1 equals plus plus, a is first increment to 6, and then result 1 is assigned the value 6. Using the postfix increment, as in result 2 equals b plus plus, result 2 is assigned the current value of b, which is 5, and then b is increment to 6. Therefore, at the end of these operations, a is 6, result 1 is 6, b is 6, and result 2 is 5. In C programming, relational operators are used to compare two values. These operators return 1 if the comparison is true, and 0 if it's false. The equal to operator denoted by 2 equals signs checks if 2 operands are equal. For example, 5 equals 5 returns 1, which means true. The not equal to operator denoted by an exclamation mark followed by an equals sign checks if 2 operands are not equal. For example, 5 not equal to 3 returns 1, which means true. The greater than operator denoted by a right angle bracket checks if the left operand is greater than the right operand. For example, 5 is greater than 3 returns 1, which means true. The less than operator denoted by a left angle bracket checks if the left operand is less than the right operand. For example, 5 is less than 8 returns 1, which means true. The greater than or equal to operator denoted by a right angle bracket followed by an equals sign checks if the left operand is greater than or equal to the right operand. For example, 5 is greater than or equal to 5 returns 1, which means true. The less than or equal to operator denoted by a left angle bracket followed by an equals sign checks if the left operand is less than or equal to the right operand. For example, 5 is less than or equal to 3 returns 0, which means false. Here is a simple illustration of using relational operators. We have integers a equals 10, b equals 5, and c equals 10. The expression a equals b returns 0, while a equals c returns 1. The expression a not equals b returns 1, the expression a greater than b returns 1, and the expression a less than b returns 0. Logical operators in C are used to perform logical operations on one or more expressions, typically used to combine relational expressions. The logical AND operator denoted by two ampersands returns true only if both operands are true. For instance, x greater than 5 and y less than 10. The logical OR operator denoted by two vertical bars returns true if either operand is true. For instance, x greater than 5 or y less than 10. The logical NOT operator denoted by an exclamation point returns true if the operand is false, and vice versa. For instance, not x greater than 5. These operators follow specific truth tables. The AND operator returns 1 only when both and b are 1. The OR operator returns 1 if either or b is 1. The NOT operator simply inverts the value of a. It's important to note that in C, any non-zero value is considered true, and 0 is considered false. As an example, consider age equals 25, and score equals 85. Age greater than 18 and score greater than 70 is true because both conditions are met. Age greater than 30 or score greater than 70 is true because the second condition is met. Not age greater than 30 is true because age greater than 30 is false and the NOT operator inverts it. Bitwise operators in C allow you to perform operations at the level of individual bits within integer values. The bitwise AND operator denoted by a single ampersand performs a logical AND on each pair of corresponding bits. For example, 5 and 3 equals 1. The bitwise OR operator denoted by a single vertical bar performs a logical OR on each pair of corresponding bits. For example, 5 or 3 equals 7. The bitwise XOR operator denoted by a caret performs a logical exclusive OR on each pair of corresponding bits. For example, 5 XOR 3 equals 6. The bitwise NOT operator denoted by a tilde inverts each bit in the operand. For example, not 5 equals -6. The left shift operator denoted by two less than signs shifts the bits of the left operand to the left by the number of positions specified by the right operand. For example, 5 left shift 1 equals 10. The right shift operator denoted by two greater than signs shifts the bits of the left operand to the right by the number of positions specified by the right operand. For example, 5 right shift 1 equals 2. Keep in mind that bitwise operators work at the binary level, manipulating individual bits of integer values. For instance, if A is 5, which is 0101 in binary, and B is 3, which is 0011 in binary, then A and B results in 0001, which is 1. A OR B results in 0111, which is 7. A XOR B results in 0110, which is 6, and a left shift by 1 results in 1010, which is 10. Assignment operators in C are used to assign values to variables. The simple assignment operator denoted by an equals sign assigns the value on the right to the variable on the left. For example, A equals B. The add and assign operator denoted by a plus sign followed by an equals sign adds the right operand to the left operand and assigns the result to the left operand. For example, A plus equals B. The subtract and assign operator denoted by a minus sign followed by an equals sign subtracts the right operand from the left operand and assigns the result to the left operand. For example, A minus equals B. The multiply and assign operator denoted by an asterisk followed by an equals sign multiplies the left operand by the right operand and assigns the result to the left operand. For example, A times equals B. The divide and assign operator denoted by a forward slash followed by an equals sign divides the left operand by the right operand and assigns the result to the left operand. For example, A divide equals B. The modulus and assign operator denoted by a percentage sign followed by an equals sign calculates the modulus of the left operand by the right operand and assigns the result to the left operand. For example, a modulus equals b. Lastly, there are bitwise operations combined with assignment such as a and equals b. As an example, if a starts as 10, the operation a plus equals b where b is 5 is equivalent to a equals a plus b, resulting in a now being 15. Then, a minus equals b is equivalent to a equals a minus b resulting in a being 10. And a times equals b is equivalent to a equals a times b resulting in a being 50. In C, operator precedence determines the order in which operators are evaluated in an expression. It's crucial to understand this order to ensure that expressions are evaluated correctly. The table presented here summarizes the precedence of operators from highest to lowest. Operators in the same category have the same precedence. Postfix operators such as parentheses, array access, arrow and dot operators as well as increment and decrement have the highest precedence and are evaluated from left to right. Unary operators such as unary plus and minus, logical not, bitwise not, increment and decrement in prefix form, typecasting, dereference, address of, and size of are evaluated from right to left. Multiplicative operators such as multiplication, division, and modulus are evaluated from left to right. Additive operators such as addition and subtraction are evaluated from left to right. Relational operators such as less than or equal to, greater than, and greater than or equal to are evaluated from left to right. Equality operators such as equals and not equals are evaluated from left to right. Logical operators such as logical and illogical are evaluated from left to right. Assignment operators such as equals, plus equals, minus equals, times equals, divide equals, and modulus equals are evaluated from right to left. For example, in the expression 10 plus 5 times 2, multiplication has higher precedence than addition, so the result is 20 and not 30. Using parentheses can override the default precedence. So, in the expression parentheses 10 plus 5, close parentheses times 2, the result is 30. In complex expressions, it's evaluated based on the precedence. So if we have x equals 5, y equals 10 and z equals 15, then x plus y times z divided by 5 minus 2 is evaluated as x plus y times z divided by 5 minus 2, which equals 33. When in doubt, always use parentheses to make your code more readable and ensure operations are performed in the intended order. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.